We are going to start now lecture 2 of chapter 8 class 11th mathematics binomial theorem. So in this lecture we will continue with some problems based upon the formulas and the results we have studied in our previous lecture. Now the first question we have over here, we have to prove that there is no term containing x raised to the power 10 in the expansion of this expression. So it is x square minus 2 by x raised to the power 18. If we write the general term over here, it is tr plus 1, that is equal to 18cr x square raised to the power 18 minus r and minus 2 by x raised to the power r. So we can write this is equal to minus 1 raised to the power r 18cr x raised to the power 18 minus r into 2 minus r into 2 to the power r. So we are talking about this power, we require it to be equal to 10. So we are saying it is 2 into 18 minus r should be equal to 10. So we get 36 minus 3r is equal to 10, and this implies us that r is equal to 26 by 3. And what r is representing, we are saying this term we are talking about, this is r plus 1 we are saying. So this r should be we are saying this should be a natural number. So it cannot be a fraction. So what we obtain from this is that the value r is equal to 26 by 3 is not possible. It means that there is no term containing x raised to the power 10. Next is find the middle term in the expansion of this value. So again we are writing tr plus 1. First thing is that this power we have, it is 12. It is the even power. So the middle term will be given by 12 by 2 plus 1th term. That is, we are interested in calculating the 7th term. If we want to calculate 7th term, it means the value of r we have, it is 6. So the answer we obtain, it is 12c6 ax raised to the power 6 into minus b by x square raised to the power 6. So if we solve this term, we will get it is minus 1 raised to the power 6, it is positive. So it is 12c6 a raised to the power 6 b raised to the power 6 divided by x raised to the power 6. Now if we talk about this term 12c6, it is 12 into 11 into 10 into 9 into 8 into 7 divided by 6 into 5 into 4 into 3 into 2 into 1. So if we look at this term, this is 6 to the 12 gets cancelled. Then we are saying this 3 gets cancelled over here, this 5 gets cancelled over here, 2 gets cancelled over here, and we are left with this term. Now if we multiply these terms, the final answer we are getting, it is 924 a raised to the power 6 b raised to the power 6 divided by x raised to the power 6. So this is the middle term in this expansion. Next is find the middle term in this expansion, and the value of n we have, it is 7. So we have two middle terms over here. One will be the term, we are saying it is 4th term, and second will be the 5th term. When we are calculating 4th term, the value of r we have, it is 3, and in this case the value of r we have, it is 4. So we have to calculate t4 and t5. So when we are calculating t4, the answer we have, it is 7c3 3x raised to the power 4 minus x cube by 6 raised to the power 3. And when we are calculating t5, we are having 7c4, it is 3x raised to the power 4 minus x cube by 6, this is power 3, and the power we will have over here, it is 4. Now on solving these terms, when we are talking about 7c3 and 7c4, both these values will be equal, and this value will be equal to 7 into 6 into 5 divided by 3 into 2 into 1. So 3 and 6 gets cancelled, so we are saying this value is 35. So both these values we are saying 7c3, this is 35, this value it is 35. In this case we will have the negative sign is there. Because of this negative sign, in this case we will not have negative sign, and the value of this term it is 3 raised to the power 4 divided by 6 raised to the power 3 into x raised to the power 13. And on solving this, we will get it is minus 105 by 8 x raised to the power 13. And on solving this second term, we will have it is 35, 3 raised to the power 3, x raised to the power 3, x raised to the power 12 divided by 6 raised to the power 4. So the answer we will have it is 35 by 48 x raised to the power 15. So these are the two middle terms in this case. Next is show that the middle term in the expansion of this is this. Now the power we have over here, it is 2n. So it means the middle term will be given by 2n by 2 plus 1th term. So answer we will have it is n plus 1th term. So the value of r we will have that is equal to n. It means we have to calculate t of n plus 1. So the answer we will get it is 2ncn. Then it is x raised to the power n. So now what we have to prove is, we have to prove that 2ncn is equal to this value. So if we look at this term 2ncn, if we open this term, we will have it is 1 into 2 into 3, so on up to, we will have some value 2n minus 2, then 2n minus 1, then 2n divided by n factorial into n factorial. I am talking about this term. Now we arrange these terms in this way. We are saying it is 1 into 3 into 5 into so on up to 2n minus 1, odd terms, and even terms we will have it is 2 into 4 into so on up to 2n divided by n factorial into n factorial. From all these terms, we are talking about these terms, we are taking 2, this is 2 raised to the power 2, this is 2 into 2, next term will be 2 into 3. So if we take 2 common, we will have 2 raised to the power, there are n terms over here, then 1 into 3 into 5 so on up to 2n minus 1. Next we have it is 1 into 2 into 3 so on up to n divided by n factorial into n factorial. So n factorial gets cancelled over here, and we obtain the final answer in this form, that it is 1 into 3 into 5 so on up to 2n minus 1 by n factorial into 2 raised to the power n into x raised to the power n we have already obtained over here. Now the next question we have is, if x raised to the power p occurs in the expansion of this expression, we have to prove that its coefficient is this. So if we write the general term over here, it is tr plus 1, that is equal to 2ncr x square raised to the power 2n minus r and 1 by x raised to the power r. So this is equal to 2ncr x raised to the power, it is 4n minus 2r minus r, and we are saying that this power we should have, that should be equal to p. So we obtain from this the value of r we obtain, that is r is equal to 4n minus p divided by 3. This is the value of r we are talking about, for which x raised to the power p will occur over here. So if we substitute this value of r, we are getting from this that it is 2nc, the value of r we have it is 4n minus p by 3. We are saying that what we have to do is we have to find the coefficient of the term with x raised to the power p. The coefficient of the term with x raised to the power p will occur when we are saying the value of r is equal to 4n minus p by 3. So we have substituted this value in this expression with whatever, this is the coefficient of this term, 2ncr is the coefficient of x raised to the power p now. So we have to evaluate this term. So we are writing this is equal to 2n factorial divided by 4n minus p by 3 factorial into 2n minus 4n minus p by 3 factorial. So this is equal to 2n factorial divided by 4n minus p by 3 factorial into, we will obtain from this, it is, when we take the LCM over here, it is 6n minus 4n, it will become 2n plus p by 3 factorial, and this is what we have to prove, that this is the coefficient that we have to prove. Next is show that the coefficient of the middle term in the expansion of 1 plus x raised to the power 2n is sum of the coefficients of two middle terms in the expansion of 1 plus x raised to the power 2n minus 1. You are seeing this is 2n over here. So the middle term we will have, it is 2n by 2 plus 1th term. So we are saying it is n plus 1th term. So the value of r we will have, it is n. When we are talking about this expansion, it has total 2n terms. So there are two middle term, one is the nth term and one is the n plus 1th term. In this case the value of r will be n minus 1, in this case the value of r will be n. And we are saying that we have to show that the middle term of this expansion, will be 2ncn x raised to the power n, and the middle term, the two middle terms we have over here, it is 2n minus 1 cn minus 1 x raised to the power n minus 1 plus, we are talking about the sum of these two terms. Next is 2n minus 1 cn x raised to the power n. Now we are interested only in the coefficients of these terms. So we are not interested in these values. We are talking about these two sums. So what we have to prove is that 2n minus 1 cn minus 1 plus 2n minus 1 cn, the sum of these two values, we have to prove that this is equal to 2ncn. So if we open these terms, we will get it is 2n minus 1 factorial divided by n minus 1 factorial into n factorial plus 2n minus 1 factorial divided by n factorial into n minus 1 factorial. So this is equal to 2n minus 1 factorial divided by, this is 2 times this value, n minus 1 factorial into n factorial. Now we want to convert this value in this form. This is basically 2n factorial divided by n factorial square. So to make this conversion, we are multiplying this term with n. Numerator and denominator we have multiplied. This term will become 2n into 2n minus 1 factorial, it is 2n factorial divided by, look at this term, it is n into n minus 1 factorial, it is n factorial. This n factorial is n factorial square. Clearly both these values, these are equal to each other, and this is what we have to prove in this question. Now the next question we have is that a1, a2, a3, a4 be the four consecutive terms in the expansion of 1 plus x raised to the power n. So suppose we are saying that a1 is rth term, this is r plus 1th term, this is r plus 2th term, and this is r plus 3th term. So what we obtain from this is that the value of a1, we will have the general term, the formula for general term t r plus 1, that is NCR x raised to the power r. So the value of A1 we will have, it is NCR minus 1. The value of A2 we have, that is NCR. The value of A3 we have, it is NCR plus 1, and value of A4 we have, it is NCR plus 2. Now if we substitute these values on the left hand side of this equation, we have A1 plus A2. We are saying A1 plus A2. If we add both these terms, the answer we will have, it is NCR minus 1 plus NCR, it is N plus 1 CR. And the sum of these two terms, it is N plus 1 CR plus 2. So if we substitute these values in this formula, we will obtain, it is NCR minus 1 divided by N plus 1 CR plus NCR plus 1 divided by N plus 1 CR plus 2. Now if we use the result that NCR is equal to N by R, N minus 1 CR minus 1, we are talking about this denominator part. So this expression will become NCR minus 1 over N plus 1 by R into NCR minus 1 plus NCR plus 1 divided by N plus 1 over R plus 2 NCR plus 1. Both these terms gets cancelled, and what we obtain is R by N plus 1 plus R plus 2 by N plus 1. So this is equal to 2 times R plus 1 over N plus 1. So we are obtaining this term, it is 2 times R plus 1 over N plus 1. Now coming to this right hand side, if we substitute the values, we will obtain the answer as, we are using the same results, we obtain the answer as 2 times R plus 1 over N plus 1. So we are saying that LHS is equal to RHS, and we obtain this result. Next is, in the expansion of 1 plus x raised to the power m plus n, we have to prove that the coefficients of x raised to the power m and x raised to the power n are equal. So if we write the general term over here, we are saying it is TR plus 1, that is equal to n or m plus n CR x raised to the power r. Now if we have to write the coefficient of x raised to the power m, it means we are substituting the value of n is equal r is equal to, we are saying, we are calculating this, so we are saying m is equal to r. So what we will obtain from this is the coefficient of this term, we are saying it will be m plus n C m, and when we are calculating the coefficient of x raised to the power n, we have it is m plus n C n, and we know that both these values, these are equal, because m plus n C m, that is equal to m plus n C m plus n minus m, this is equal to m plus m n C n. So both these values, these are equal, and this is what we have to prove, that the coefficients of x raised to power m and x raised to the power n, they are equal. Next is, find the value of r when it is being given that coefficient of 2r plus 4th and r minus second term in the expansion of 1 plus x raised to the power 18 are equal. So the general term, if we write the value of t, we are using p plus 1 because we have the variable r used over here. So that will be equal to 18 cp x raised to the power p. Now we are talking about 2r plus 4th term, means we are talking about 2r plus 3 plus 1th term. So that will be 18c 2r plus 3 x raised to the power 2r plus 3. Next we are talking about t of r minus 3 plus 1. it is 18c r minus 3 x raised to the power r minus 3. Now we have to find the value of r for which both these coefficients these are equal. So when we are equating these coefficients, we are saying 18c 2r plus 3 that is equal to 18c r minus 3. So this implies us that 2r plus 3 is equal to r minus 3, or 2r plus 3 plus r minus 3 is equal to 18. These conditions we already know, that if NCP is equal to NCQ, then either P is equal to Q or P plus Q is equal to N. This thing we have studied when we have studied the combinations chapter and the properties of the binomial coefficients over there. So if we solve both these equations, from this first equation we will obtain the value of r as it is r is equal to minus of 6, and from this second equation we will obtain 3r is equal to 18, so r is equal to 6. We know that the r is the term over here we are talking about, so this negative value of r is not possible, so the only permissible value of r we have, it is r is equal to 6. So this is the only value of r possible in this case. Next is find the coefficient of x raised to the power 6 y cube in the expansion of this term. So if we write the general term tr, it is 9cr x raised to the power 9 minus r 2y raised to the power r. Now we require 9 minus r is equal to 6 and r is equal to 3. So we are interested in the value, this is t of r plus 1, we are interested in the value of r is equal to 3. So the coefficient we will have over here, that is 9c3 2 raised to the power 3. So that is equal to 9 into 8 into 7 divided by 3 into 2 into 1 into 8, and on solving this the answer we get, it is 672. So we are saying the coefficient of x raised to the power 6 y cube in the expansion is 672. Next is write down the binomial expansion of 1 plus x raised to the power n plus 1 when x is equal to 8, and hence we have to deduce that 9 raised to the power n plus 1 minus 8n minus 9 is divisible by 64. So if we write the expansion over here, we are saying it is 1 plus x raised to the power n plus 1. So the expansion is n plus 1 c0 plus n plus 1 c1x plus n plus 1 c2x square plus so on up to n plus 1 cn x raised to the power n plus n plus 1 cn plus 1 x raised to the power n plus 1. Now if we substitute x is equal to 8, if we substitute in this x is equal to 8, we will get 9 raised to the power n plus 1, that is equal to the value of n c0 we have, it is 1, plus n plus 1 into 8, n plus 1 c2 8 square plus so on up to n plus 1 cn 8 raised to the power n plus this last term we will have, it is 8 raised to the power n plus 1. Now look at this term over here, we are saying this is 1 plus 8 plus 8n plus all these terms are there. This value, this will become 9. Now if we shift all these terms on this side, we will obtain 9 raised to the power n plus 1 minus 8n minus 9, that is equal to, now from all these terms, from all these remaining terms, we can take 8 common and we are left with is n plus 1 c2 into 8 plus so on up to this value is n plus 1 cn 8n minus 1 plus 8 raised to the power n. Further, if we take 8 square common from this, this term will become 1, this will become minus 2, and this term will become 8 raised to the power n minus 1. And 8 raised to power 2 means we are saying it is 64. Suppose this whole term we are writing it is k, so we are writing this is 64 times some number k, and this thing proves that this expression 9 raised to the power n plus 1 minus 8n minus 9 is divisible by 64. Next is using binomial theorem prove that 6 raised to the power n minus 5n always leaves the remainder 1 when divided by 25. So we start with this. We are talking about 6 raised to the power n. We can write it as 1 plus 5 raised to the power n. This term 5n we have, and we are talking about the multiplication with 25. So if we expand 1 plus 5 raised to the power n, answer we will obtain it is nc0 plus nc1 into 5 plus nc2 into 5 square, so on up to ncn into 5 raised to the power n. Now we are saying, look at this term over here. This term we have it is 5n, this term we have it is 1. So if we subtract 5n from both sides, these two terms will be cancelled, and what we are left with is 6 raised to the power n minus 5n, that is equal to 1 plus, from the remaining terms, we are talking about all these terms, we can take 25 common. If we take 25 common, we are left with is nc2 plus nc3 5, so on up to plus ncn 5 raised to the power n minus 2. This whole expression we can write it as sum k. So what we are getting is that 6 raised to the power n minus 5n is equal to 1 plus 25k. So this thing proves that if we divide 6 raised to the power n minus 5n with 25, the remainder will be equal to 1. This is the remainder that we will have, and this is what we have to prove. Next is show that 2 raised to the power 4n plus 4 minus 15n minus 16 is divisible by 2 to 5. Now 2 to 5, it is the square of 15. So if we look at this term over here, we can write it in the form 2 raised to the power 4 into n plus 1. So that will become 16 raised to the power n plus 1. So this whole expression can be written as 16 raised to the power n plus 1 minus 15n minus 16. So if we look at this term, so we are basically interested in 1 plus 15 raised to the power n plus 1. If we expand this term, we will get it is n plus 1 c0 plus n plus 1 c1 15 raised to the power 1 plus n plus 1 c2 15 square plus so on up to plus n plus 1 cn plus 1 15 raised to the power n plus 1. We will obtain over here it is n plus 1. Now this term we are saying n plus 1 c0, this is 1, n plus 1 c1, it is n plus 1. So what we are obtaining from this is, we are writing it is 16 raised to the power n plus 1, that is equal to 1 plus 15n plus 15 plus 15 square is common. From all these terms we are saying we can take 15 square common, and the remaining value, suppose we are writing it is k. So on adjusting these terms, we will obtain 16 raised to the power n plus 1 minus 15n minus 16, that is equal to 15 square into k. So this thing gives us that this term is divisible by 2 to 5. Next we have is, if a and b are distinct integers, we have to prove that a minus b is a factor of a raised to the power n minus b raised to the power n whenever n is a positive integer. So to prove this result, we start with this thing. We are saying that a, we can write it is equal to a minus b plus b. If we write a raised to the power n, that will be a minus b plus b raised to the power n. So this is equal to, we are saying, a minus b plus b whole raised to the power n, and when we open these terms, it is nc0 a minus b raised to the power n plus nc1 a minus b raised to the power n minus 1 into b raised to the power 1. So this power over here, it is n, and we have the term b over here. And likewise, if we continue, we get it is ncn minus 1 a minus b into b plus ncn into b raised to the power n. Now the value of these terms we are talking about, nc0, this is 1, and the value of ncn, this is 1. So what we are left with is that a raised to the power n, that is equal to a minus b raised to the power n plus nb into a minus b raised to the power n minus 1 plus so on up to plus nb n minus 1 a minus b plus b raised to the power n. Now if we subtract b raised to the power n on both sides, this term gets cancelled, and we can write a raised to the power n minus b raised to the power n, that is equal to a minus b into a minus b raised to the power n minus 1 plus nb into a minus b raised to the power n minus 2 plus so on up to plus nb n minus 1, and this whole term we can write this is equal to some number k, and this result proves that a raised to the power n minus b raised to the power n is divisible by a minus b. Now next we have is, if the coefficient of r plus 1th, rth and r minus 1th terms in the expansion of x plus 1 raised to the power n, they are in the ratio 1:3:5. So we are saying, if we are talking about t r minus 1, that will be equal to n c r minus 2 x raised to the power r minus 2. When we are saying t r, so that is equal to n c r minus 1 x raised to the power r minus 1, and t r plus 1 is equal to n c r x raised to the power r, and it is given that the ratio of these three, it is 1:3:5. So coefficients we are talking about, so it is n c r minus 2 is to n c r minus 1 is to n c r, it is given to be equal to 1:3:5. So if we compare from these terms, if we calculate from these terms, we will obtain that n c r minus 2 over n c r minus 1 is equal to 1/3, and n c r minus 1 over n c r, this is equal to 3/5. So if we calculate these values, we are talking about the value of n c r minus 2. So that value will be equal to n factorial over r minus 2 factorial into n minus r plus 2 factorial into, this term will be n factorial r minus 1 factorial into n minus r plus 1 factorial, and this value is equal to 1/3. Now n factorial gets cancelled. Now we are talking about the term r minus 1 factorial. We can write these two terms get cancelled, and we are left with is r minus 1. And if we write this term, we can write it is r minus 2 plus 2 into n minus r plus 1 factorial. So both these terms gets cancelled. So what we have obtained from this is that r minus 1 over n minus r plus 2 is equal to 1/3. Similarly, if we solve this term, we will obtain that r over n minus r plus 1 is equal to 3/5. So we obtain two linear equations in n and r. One is n minus 4r is equal to minus 5, and this will implies us 3n minus 8r is equal to minus 3. So these are the two equations given over here. These are the two equations we are talking about. And if we will solve these equations, we will obtain the final answer as n is equal to 7 and r is equal to 3. So these are the values of n and r that we have. Next is, if the coefficient of x raised to the power r minus 1, x raised to the power r and x raised to the power r plus 1 in the binomial expansion of 1 plus x raised to the power n, they are in AP. So if we write the terms over here, we are writing the coefficients over here. So we are saying coefficient of x raised to the power r minus 1. If we write the general term, it is tr plus 1. That is equal to ncr x raised to the power r. So coefficient of x raised to the power r minus 1, it is ncr minus 1. Then ncr and ncr plus 1, these three terms are given to be in AP. So what we obtain is that 2 times ncr, that is equal to ncr minus 1 plus ncr plus 1. So if we solve these terms, we will obtain that 2 is equal to, if we divide on this side, it is ncr, we divide on this side, it is ncr, and when we open these terms, as we have done in our previous slide, we are saying that this answer will be r over n minus r plus 1, and this answer will be n minus r over r plus 1. And on solving this term, if we take the LCM over here, we will obtain that 2 is equal to r square plus r plus n minus r into n minus r plus 1 divided by n minus r plus 1 into r plus 1. We cross multiply these terms and simplify these values. When we simplify this term, we will obtain the final answer in this form, that it is n square minus n times 4r plus 1 plus 4r square minus 2, and this is what we have to prove. So we are saying if we simplify this value, we will obtain this given, we will obtain what we have to prove. Next is simplify the expression. This expression is being given. So it is 1 plus x raised to the power 1000, x into 1 plus x raised to the power 999, x square, then x raised to the power 1000, and we have to find the coefficient of x raised to the power 50. So if we look at these terms and we divide these two values, we obtain it is x into 1 plus x raised to the power 999 divided by 1 plus x raised to the power 1000. Answer we obtain it is x over 1 plus x. Similarly, if we divide these two terms, we will obtain the answer as, this is x square into 1 plus x raised to the power 998 divided by x into 1 plus x raised to the power 999. This gets cancelled, this gets cancelled, and again the answer we get, it is x over 1 plus x. So we are saying this is a GP whose common ratio is x over 1 plus x. Now the first term we have over here, a is equal to 1 plus x raised to the power 1000, and the value of n we have, that is equal to 1001. Now sum of this finite GP, that will be given by 1 plus x raised to the power 1000 a into 1 minus x over 1 plus x raised to the power 1000. It is 1000, 1 raised to the power n over 1 minus x over 1 plus x. If we look at this term, it is 1 plus x minus x over 1 plus x. So this will give us 1 plus x raised to the power 1001 into 1 minus x raised to the power 1001 divided by 1 plus x raised to the power 1001. So if we multiply these terms, we will obtain this is equal to 1 plus x raised to the power 1001 minus x raised to the power 1001. Now if we expand this term 1 plus x raised to the power 1001, we are saying if we expand this term using the binomial theorem, the answer we will have it is 1 plus 1001 c1x plus 1001 c2x square plus so on up to 1001 c1000 x raised to the power 1000 plus x raised to the power 1001 minus x raised to the power 1001. Now these two terms gets cancelled and we are left with this expression. We are saying that on simplifying this value we are obtaining this. Now we have to calculate the coefficient of x raised to the power 50. We have to find the coefficient of x raised to the power 50. So from this expression, from this expansion, the coefficient of x raised to the power 50 will be 1001 c 50. So this is the required answer. We are saying 1001 c 50 is the coefficient of x raised to the power 50. Next is, if n is a positive integer, find the value coefficient of x raised to the power minus 1 in the expansion of this. So we are having 1 plus x raised to the power n into 1 plus 1 by x raised to the power n. We can write, if we take LCM over here, it is x plus 1 over x. So this is equal to 1 plus x raised to the power 2n divided by x raised to the power n. So we are saying the coefficient of this term we have to calculate. Now if we expand this numerator part, we will have 2nc0 plus 2nc1x plus 2nc2x square plus so on up to 2ncn x raised to the power n plus 2ncn plus 1 x raised to the power n plus 1 plus so on up to 2nc2n x raised to the power 2n, and whole is divided by x raised to the power n. And we have a term over here. Before this term we would have 2ncn minus 1 x raised to the power n minus 1. Now if we divide these terms, what we require is, we require the coefficient of x raised to the power minus 1, and we can see that on dividing this term with x raised to the power n, the coefficient of x raised to the power minus 1 will be the coefficient of this term. So it is 2ncn minus 1, because we are dividing it with x raised to the power n. We have 2ncn minus 1 x raised to the power n minus 1 over x raised to the power n. Now look at this term, it is x raised to the power n minus 1 minus n. So it is equal to x raised to the power minus 1. So we are saying the coefficient of this term is 2ncn minus 1. This value we are saying. Next is, find the coefficient of x raised to the power 4 in the expansion of this term. So we are writing it in the form 1 plus x square into 1 plus x whole raised to the power 11. So this is equal to 1 plus x into 1 plus x square whole raised to the power 11. Now if we expand both these terms, it is 1 plus x raised to the power 11 into 1 plus x square raised to the power 11. The answers we will have, in this case it is n 11c0 plus 11c1x plus 11c2x square, so on up to 11c11x raised to the power 11. In the second term we will have 11c0 plus 11c1x square plus 11c2x4, so on up to plus 11c11x raised to the power 22. Now we are interested in calculating the coefficient of x raised to the power 4, and x raised to the power 4 we will obtain by multiplying x square with x square and by multiplying this constant term with x raised to the power 4, and there will be a term over here with x raised to the power 4 and this constant term. So we are saying the answers we will have it is 11C0 into 11C2 into x raised to the power 4 plus 11C2 into 11C1 into x raised to the power 4, these two terms, and we will have two more terms. It is 11C0 into 11C4 x raised to the power 4. So we are saying the answer we obtain, it is equal to the value of 11C0 we have, it is equal to 1. The value of 11C2, it is 11 into 10 divided by 2 plus 11 into 10 divided by 2, then it is 11, then it is 1, then it is 11 into 10 into 9 into 8 divided by 4 into 3 into 2 into 1. This is the coefficient of x raised to the power 4. So this is equal to, this is 55 plus 55 into 11, it is 605 plus this 8 gets cancelled, this 9 gets cancelled, and the answer we obtain, it is 330. So the final answer we obtain, it is 990. So we are saying that this value 990 is the coefficient of x raised to the power 4 in the given expansion. Next is find the coefficient of x raised to the power 4 in the expansion of this term, this expression. So we expand both these expressions. For the first one, it is 4C0 plus 4C1 2x plus 4C2 2x square plus 4C3 2x cube plus 4C4 2x raised to the power 4. And the second term, when we expand this second term, it is 2 minus x raised to the power 5. So we are writing it is 5C0 2 raised to the power 5 plus 5C1 2 raised to the power 4 into minus x raised to the power 1. Next it is plus 5C2 2 raised to the power 3 minus x raised to the power 2 plus 5C3 2 raised to the power 2 minus x raised to the power 3 plus 5C4 2 raised to the power 1 minus x raised to the power 4 and plus 5C5 minus x raised to the power 5. Now again we require the values corresponding to the coefficient, it is x raised to the power 4. So we are saying this C0 4C0, it is to be multiplied with 5C4 into 2 and it is x raised to the power 4, so this will be positive. Next it is plus, we move on to the second term, it is x over here, it is to be multiplied with this term. So it is 4C1 into 2 into 5C3 into 2 raised to the power 2 into minus 1. Next we move on to our next term, it is x square over here. So it is 4C2 2 raised to the power 2, it is to be multiplied with 5C2 2 raised to the power 3 and it is plus 1 over here. Next we move on to our next term. So we get it is 4C3 2 raised to the power 3. It is to be multiplied with 5C1 2 raised to the power 4 into minus 1, this term. And last we are saying it is 4C4 2 raised to the power 4. This term is to be multiplied with this first term, it is 5C0 2 raised to the power 5. Now on solving this, the coefficient, these coefficient 4C0 it is 1, 5C4 will be 5, 4C1 will be 4, 5C3 will be 10, then we have 4C2. So the value of 4C2 will be, this value we will have 6, 2 raised to the power 2 is 4, 2 raised to the power 2 is 4, this is 8 and 5C2 this value will be 10. Next 4c3 will be 4, 5c1 will be 5, 2 raised to power 3 will be 8, 2 raised to power 4 will be 16, 4c4 will be 1 and 5c0 will be 1. Then 2 raised to power 4 will be 16 and 2 raised to power 5 will be 32, and if we solve all these values, the final answer we will obtain on solving this, that will be minus 438. When you solve all these values, you make this calculation, these minus sign you should consider while solving these values. So the final answer you will obtain, it is minus 438. Next is, if P be the sum of all odd terms and Q be the sum of all even terms in the expansion of x plus a raised to the power n, we have to prove these three results. So if we are talking about the even and odd terms, it means we are considering the case that t1 plus t3 plus t5 plus so on plus t2 plus t4 plus t6 so on, that is equal to p, odd terms is p and even terms it is q. And if we calculate the values of these terms, we are saying we are using the expansion over here, so we will have x plus a raised to the power n, that is equal to nc0 x raised to power n plus nc1 x raised to power n minus 1 a plus so on up to ncn a raised to the power n, and we are saying that this value is equal to p plus q in this form. Now if we calculate the value of x minus a raised to the power n, we will have, it is minus sign over here. So if it is minus sign, it means this term will be negative, then the next term will be negative. So this is the first term, this is the second term. So what we are getting is that t1 minus t2 plus t3 minus t4 so on up to, we obtain in this way. We can write this is equal to t1 plus t3 so on up to minus t2 plus t4 so on up to, we are writing this is equal to p minus q. So we are having two expressions over here. First is that x plus a raised to the power n, that is equal to p plus q, and second is p minus q is equal to x minus a raised to the power n. We are talking about these two expressions over here. Writing this value, it is x plus a raised to the power n is p plus q and x minus a raised to the power n is p minus q. Now if we multiply both these expressions, we will obtain x minus a raised to the power n into x plus a raised to the power n is equal to p plus q into p minus q, and this gives us the first result that we have to prove, that p square minus q square, that is equal to x square minus a square raised to the power n. Second we have to prove is that 4 times pq is equal to this value. So if we square and add both these equations, we are talking about these two equations, if we square and add both these equations, we will have x minus a raised to the power 2n. We want to subtract over here, so we are saying x plus a raised to the power 2n minus x minus a raised to the power 2n. We obtain the value is equal to p plus q square minus p minus q square. So the answer we will obtain, that is equal to 4 times p into q. So this is the second part we have to prove, and in the third part we are going to square and add both these terms, and if we add these terms we will obtain the answer in the form. It is clear from here that if we add these terms, in place of subtracting these terms, if we add these terms, we will have plus sign over here, and the answer we will obtain, it is 2 times p square plus q square, and this is the third part that we have to prove. Next is use binomial theorem to find the value of 103 raised to the power 4. So we can write this 103 as 100 plus 3 raised to the power 4. So if we use the binomial theorem, we know the expansion we will have, it is 100 raised to the power 4 plus 4 into 100 raised to the power 3 into 3 plus 6 into 100 raised to the power 2 into 3 raised to the power 2 plus 4 into 100 into 3 raised to the power 3, and last it is 3 raised to the power 4. So the answer we will obtain, this is equal to 100, 00, 00, 00, 00 plus 12 this term, then it is 54 and 0, 0, 0, 0, and then the next term we will have, it is 108 and then it is 0, 0, and last term we will have, it is 81, and if we add all these values we will obtain the final answer in the form, it is 1125 50881. So this is the final answer we obtain in this case. Next is using binomial theorem, find the value of 99 raised to the power 4. So we are writing it is 100 minus 1 raised to the power 4. So binomial coefficients we have, it is by using binomial theorem, it is 100 raised to the power 4 minus 4 into 100 cube plus 6 into 100 square minus 4 into 100 plus 1. So we are getting it is 10 minus 4 0 0 0 0 0 0 plus 6 0 0 0 0 minus 400 plus 1, and when we will solve this value we will obtain the answer as 96059,610. So this is the answer for this value. Next is use the binomial theorem to find the value of this term. So we can write 0.99, this is raised to the power 15, we can write this is 1 minus 0.01 raised to the power 15. So if we use the binomial theorem over here, we are saying the first term we will have, it is 1, then it is minus 15 into 0.01, we have to find up to 4 decimal places, answer we require up to 4 decimal places. Next value we will have, it is 15C2, so we are writing it is 105 into 0.0001. Next it is 15C3, it is minus sign over here now, it is 455 into 0.000001, and we have some other terms over here, but all these terms will have, look at this term, it will be, these smaller terms are there, the smaller terms are there, but we require the answer up to 4 decimal places, so we can neglect these smaller terms. So we are saying that what we are left with is 1 minus 0.15 plus 0.0105 plus 0.000455, and on solving this you will get 0.860045. So this is the value of 0.99 raised to the power 15, correct up to 4 decimal places. Next is using the binomial theorem, prove that 101 raised to the power 50 is greater than this value. So if we write 101 raised to the power 50 is equal to A, and 100 raised to the power 50 plus 99 raised to the power 50 is equal to B, and we are calculating the value of A minus B, we will obtain it is 101 raised to the power 50 minus 100 raised to the power 50 minus 99 raised to the power 50. You can write this is equal to 100 plus 1 raised to the power 50 minus 100 raised to the power 50 minus 100 minus 1 raised to the power 50. Now if we expand all these terms, we will get at it is 50C0 100 raised to the power 0 plus 50C1, it is 100 raised to the power 1, then it is 50c2 100 raised to the power 2, so on up to plus 50c 50 and 100 raised to the power 50. The second term we have, it is 100 minus 100 raised to the power 50, and from the expansion of this last term, the expansion of this last term will be 50c0 100 raised to the power 0. Next it is, because of this minus sign we are saying, it is minus 50c1 100 raised to the power 1, then it is plus 50c2 100 raised to the power 2, and continuing in this way, the last term we will have, it is with plus sign, and that will be 50c50 100 raised to the power 50. Now if we put the signs over here, the signs we have, it is, for this term it is negative sign, for all these terms these are negative signs. So what we obtain is that this term gets cancelled, this term gets cancelled, these two terms gets cancelled, and what we are left with is 2 times 50c1 into 100 plus 50c2, this term is getting cancelled, it is 50c3 into 1000, and so on up to the second last term we will have, it is 50 plus 50c49 into 100 raised to the power 49 minus 100 raised to the power 50. Now look at this term over here, we are saying 50c49, that is equal to 50c1, that is equal to 50. When this term is multiplied with 100 raised to the power 49, this term will become 100 raised to the power 50. So what we obtain from this is, we are having two terms now. One is this whole term we are talking about, and this term, all these terms, these are positive, they are being added, and we are having 100 raised to the power 50 in this. And the second term we are saying, it is this term, it is 100 minus 100 raised to the power 50. So from this result we can see that this whole value is greater than 0. So what we obtain is that a minus b is greater than 0. So this implies us that a is greater than b, and this is what we have to prove, that a is greater than b. Next is, which is larger, 1.01 raised to the power this number or 10,000. So again we are considering 1.01 raised to the power 100,0000 minus 100,000. Now this term we can write, it is 1 plus 0.101 raised to the power 100,0000. If we expand this term, the first term we will have, it is 1, the next term we will have, that will be 0.01 into 100,0000 plus some other terms are there. I am talking about only the first part over here. First part means we are talking about this number. We can write it in this form. We are talking about the expansion of this. We will have some terms over here. Now look at this value. We have 2 zeros over here and we have 6 zeros over here. So the answer we have, it is 100,0000. Now if we add both these terms, we will have 100,01 plus some other positive terms. Now we come to this term. We are saying we have another term over here, that it is minus 100,000. Look at these two terms. The answer we will have, it is 1 plus some positive terms. It means that this value is greater than 0. So what we obtain is that 1.01 raised to the power, this is greater than because this value we are saying it is greater than 0.